Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we're going to continue with Chapter 3 word problems. And actually, I don't know why I put part 1 here already. My first typo. Sorry. And this is part 2. Today we're going to talk about, remember how I said there was 5 different types of word problems? We've already done the percents and the direct translation, rather. Now we're going to do uniform motion, and we're going to do geometric as well. And then we have work problems also to do later, and mixture, but we'll get to that later. Uniform motion word problems, guys. This is a distance, rate, and time problem. These are the type of problems that it says train A left the station at 5 o'clock, train B left it at, a half hour later. Train A is going 5 times faster than train B. When are they both going to be this far apart? Do you remember all those that sometimes we just forget to even look at because it's too many words, it's just scared, and you're like, I don't know what to do. Hopefully we're going to demystify motion word problems today. First thing I want you guys to understand is that distance equals rate times time. D, which is distance, equals R, which is the rate. The rate is speed. Sometimes rate is a percentage. In this particular case, since it's distance, R is rate speed. And T is time, not in any particular denomination. It's not necessarily hours or minutes or seconds or days or weeks. It's just time depending on the particular problem. But that's first things first. We're talking about uniform motion word problems, guys. You got to know that distance equals rate times time. Next, there are 3 types of uniform motion problems. A lot of people ignore this part of the lesson. Please don't ignore it. This is what really makes it or breaks it for you, in my opinion. Number 1, you have a situation, guys, where what's happening is you're starting A, okay, and A is headed towards the right, and B is headed towards the left, and they have a total distance, bless you, in between them, okay? That's one type of distance problem, where they're both starting at opposite ends and they're going towards each other. When will they meet? A second type of situation is you have a starting point here, A, and one train goes one way, another train goes another way. When are they going to be X apart from each other? X feet, X miles, whatever it is. And the third type of distance problem could be where this first dude, A, or dudette, he or she starts going, but the second person waits a little bit before they go. And then they go, but they're going to go faster than the first person, and eventually they do catch up. Okay? So those are the 3 distance problems. You're either going to have a situation where 2 objects are going towards each other, apart from each other in opposite directions, or I'm catching up with the other. If you guys can see that and literally visualize that and even draw yourself a little sketch, a little figure, whenever we're solving these problems, I promise you let me not promise you that. I promise you it helped me. I think strongly that it will help you as well. Now, in addition to knowing how the distance problem is going to go, whether it's going towards each other, opposite directions, or I'm catching up, we're going to use this magical table here, okay? And I'm not being sarcastic. This is a magical table. This table is what saved my life when it came to teaching word problems and understanding word problems. When I came up with this, I just was like, oh, okay, I get it. So we have an event, okay? I don't know what the event's going to be. Maybe it's train A, maybe it's train B, maybe it's going against the wind, maybe it's going with the wind, maybe one is headed east, maybe one is headed north, maybe one is headed south, maybe I don't know what the event is, but there's going to be 2 events. 2 different things are happening. You're going to have the rate of event 1 and the rate of event 2, the time for event 1, the time for event 2, and then remember that distance is rate times time. So the distance of rate 1 and the distance of rate 2. From there, I don't know how we're going to solve it. Depends on the question. But right now, what you need to know is that distance equals rate times time. 3 different types of distance word problems we can have. And the table of magic. Okay? Does that make sense so far? Pretty simple, right? Pretty good. All right? Promise you, follow these setups. Let's get to it, guys. No fear, okay? No fear. Frank and Mike drove from Atlanta, Georgia to Durham, North Carolina, which are 390 miles apart. Their average speed for the first part of the trip was 60 miles per hour. Due to road work, their average speed for the remainder of the trip was 45 miles per hour. How long did they travel at 45 miles per hour if they drove 3 hours longer at 60 miles per hour than 45 miles per hour? This is usually where people say, okay, I don't get it. Well, please don't do that. Please, let's just analyze. Let's read carefully and let's read slowly. And most importantly, let's set up this quote-unquote magical table. Let's see how magical this table really is. Rate times time equals distance. And I have the event here. We have 2 things going on here, right? They're going from Atlanta, Georgia to North Carolina. It's 390 miles apart. But there's 2 parts of the trip. The first part of the trip, they were going really well at 60 miles per hour. So the first part of the trip, I'm traveling at 60 miles per hour. Does that make sense so far? Due to road work, though, their average speed for the remainder of the trip, so I'm going to put second part of the trip here, their average speed was 45 miles per hour. So I'm literally going to fill in the blank. Okay. Now, how long did they travel at 45 miles per hour if they drove 3 hours longer at 60 miles per hour than at 45 miles per hour? What do we know nothing about? Yes, sir, my brother. That's right. You have no idea how long they travel for 45 miles per hour. How long did they travel, though, at 60 miles per hour? 3 hours longer. Not 3, guys. 3 hours longer. So that would be x plus 3. I'm going to stop for 1 second. Be honest with me. Does that make sense? A lot easier than you had ever anticipated, right? Talk to me. You shook your hand. Talk to me. Okay. The x plus 3. Doesn't it say here, my brother, how long did they travel at 45 miles per hour if they drove 3 hours longer at 60 than 45? Thank you, my brother. Thank you, my brother. Does that make sense, gentlemen? Now, here's the key. What's the distance of the first part of the trip? Not 60, guys. Doesn't distance equal rate times time? So the distance equals 60 times x plus 3, doesn't it? And what's the distance of the second part of the trip? 45x. Now, let's picture what's going on here. We had a first part of the trip where I'm going ahead and I'm traveling. All right, woohoo! I'm going at 60 miles per hour and everything is dandy. Right? This is my starting point. Oh, no, we got road work now. Well, now we broke up into a second part of the trip. So now from here to where we got to go, we were going at 45 miles per hour, correct? So didn't I, in essence, I traveled my first distance of 60 times x plus 3, plus, didn't I drive the distance of 45x? So isn't the distance of the first part of the trip plus the distance of the second part of the trip, doesn't that equal the 390? I'm going to stop right there for a second. Analyze, guys. For once, don't be afraid of this. Look at how easy I made this. Does this make sense to you? Because I'm not going to move forward until I know that my boys are good. Now you just got to solve. Yes, sir. So now I've got 60x plus 180 plus 45x equals 390. So I've got 105x equals, subtract 180 to both sides. What's that, 210? Divide by 105. And x equals 2. 2 what, though? What is this 2? What am I looking for here? Yeah, this is hours. So, what's the answer to my question? What are they looking for here, guys? Read. How long do they travel at 45 miles per hour? So isn't this the x right here? 2 hours, right? How long do they travel at 60 miles per hour, just for giggles? 5 hours. Very good. But I'm asking for how long do they travel at 45 miles per hour? So my answer would be 2 hours. Be honest, guys. You may not have liked it, but I bet you money you've never seen it this easy. Right? Thank you, my brother. Let's do another one. Okay. 2 groups of friends took a canoe trip down the New River, which, by the way, just useless fact. There are 3 rivers on Earth that flow north. All other rivers flow south. One of them is the New River in North Carolina. One of them is the St. Johns River here in Florida. And the other is the Nile. Very good. Very good. The Nile in Egypt. All right. Some useless facts there. All right. So two groups of friends took a canoe trip down the New River. The first group left canoe outpost at 12 noon. 1/2 hour later, the second group left the canoe outpost, paddling at an average speed that was 0.75 miles per hour faster than the first group. At 2:30, the second group caught up to the first group. How fast was each group paddling? Let's picture what's happening. Group 1, oh, I love it when it does that. That is my favorite. Group 1 started and they just started canoeing. But then group 2 started a little bit later. But they got to go faster in order to catch up, right? They're trying to catch up. So this is what's happening here. Can you tell me something about the distance of group 1, though, and the distance of the second group? Can you tell me something about their distances by looking at this table here, at this little figure? No? What is it? What is their final distances here? The same, guys. Guys, if I catch up to you, didn't I go the same distance as you? Let's say you go to Orlando, okay, and you get there at 5, and we both start here at school. Same spot, right next to each other in the parking lot. But you leave and you get there at 5. I leave and I get there at 9. Did we go different distances? Same distance. Does that make sense? That's why I like picturing these little figures here. So let's do the little table. You got group 1 and you got group 2. Rate times time equals distance. What was the rate of group 1? Unknown. X. What's the rate of group 2? X plus 0.75 because it's miles per hour. We don't have to do any conversions. We're golden. Now, what time did the first group leave? 12. Okay. And when did the second group leave? I'm sorry? They left at 12:30, a half hour later. So, if they both arrived at 2:30, how many hours did the first group travel? 2.5 hours. Very good. How long did the second group travel? No. 2 hours, because it's half hour less, right? If they left at 12 and then I left a half hour later, I left at 12:30. From 12:30 to 2:30 is 2 hours. Are you with me here, guys? What is the distance of the first group? Rate times time equals distance, guys. 2.5x. What's the distance of the second group, brothers? You got to distribute the 2, so very good. It's 2 times parentheses x plus 0.75, so that's 2x plus 1.5. Now, does everyone see what I've done so far? Sorry, 0.75, not 15. Yes, someone has a question. I'm here for you. Thank you, my brother. Now, didn't we already in our little sketch here, in our little figure? Oh, I was right then. Oh, okay. Thank you. Thank you. Sorry. I shouldn't have listened to my students who were not following directions. My bad, my bad. It's all right. We all make mistakes. I make mistakes all the time. Thank you, brothers, for caring. Thank you for getting my back. So now, guys, think about it. Remember, they both start at Canoe Outpost. Group 1 gets to where they're going. They get there by 2:30. Group 2 leaves later, so they got to go faster, but don't they get to where they're going, which is the same exact place? So isn't the distance of the first group equal to the distance of the second group? Does this make sense, my brothers? Awesome. So now let's solve. So I'm going to subtract 2x to both sides. And I've got 0.5x equals 1.5 divided by 0.5 divided by 0.5. X equals 3. Okay. 3. Now 3 what? What are we looking for here? 3 miles per hour. Very good. But what are we looking for here? How fast was each group battling? So group 1 was 3 miles per hour. And then group 2 was 3.75 miles per hour. Talk to me, brothers. Talk to me. Does it make sense? Be honest. It's easier than before? Right? All right. Yes, sir, my brother. How did I get the 3? Because I solved. When I go 1.5 divided by 0.5 is 3, my brother. Thank you for asking, sir. Yes, sir, my brother. No, there were no key words. I just drew it out. Think about it. Two groups of friends took a canoe trip down the New River. The first group left at 12. 1 half later, the second group left the canoe outpost paddling average speed. That was faster, blah, 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 blah. At 2:30, the second group caught up with the first group. Think about it. I leave, and I'm here at 12:30. You leave later, but eventually you catch up to me. Aren't my distances equal? Think about it, guys. Look, you live 5 miles away at your house, okay? You and your brother leave the same movie theater, walking to your house, okay? You get there at 12 o'clock at night. He gets there at 2 o'clock at night. Did you go any different distances? You both went 5 miles. Yes, one of you was slower, one of you was faster. We're going to continue with this on Monday. Thank you. God bless you, and I hope this is starting to make sense. Have a great day. Homework is not valid because we did not finish. However, prep works is valid. Have a great day. God bless you. Study the first part of the chapter 3 word problems, please. Thank you. Have a great day. Bye-bye.